In 2019, a region of the Indian Ocean, roughly the size of Iceland, began glowing. Not for seconds, but for more than 40 nights. The light was so vast that satellites could detect it from space. Then a yacht sailed directly into it. The crew of the Ganesha crossed from black water into a pale, luminous sea stretching to every horizon. One crew member compared it to sailing across snow beneath a moonless sky. This was not normal blue bioluminescence, ordinary glowing plankton flash when waves or boats disturb them. But this ocean shone continuously. Even the yacht's wake appeared darker than the water around it. Scientists call this phenomenon a Milky Sea. Sailors have reported similar events for centuries, describing oceans that looked like milk, molten metal, or endless snow. But for generations, researchers had little more than eyewitness stories. Milky Seas are extremely rare and usually appear far from land. By the time scientists hear about one, the glowing water may already have drifted away or disappeared. That is why the first major physical clue did not arrive until 1985. A research ship near Socotra collected samples from a Milky Sea. The water contained luminous bacteria called Vibrio harveyi, associated with microscopic algae. Scientists finally had a likely source of the light, but they still could not explain its enormous scale. The leading explanation involves quorum sensing. These bacteria release chemical signals into the water. As their population grows, the signals become stronger. Once enough bacteria gather, entire colonies may switch on their light-producing genes together. But something must concentrate them across an area larger than some countries. One hypothesis begins with a massive algal bloom. As algae become stressed or die, they release material that bacteria can feed on. Rotating currents may then trap this mixture inside warm, productive water for weeks. The idea is plausible, but the complete process has never been observed while a giant Milky Sea was forming. Scientists still do not know what triggers the glow, how deep it extends, or what it means for the ecosystem. For decades, these events were almost impossible to confirm. Then researchers matched a 1995 ship report off Somalia with a faint luminous patch in satellite images. For the first time, a Milky Sea seen from a ship had also been detected from orbit. Modern low-light satellites transformed the search. Reviewing observations from 2012 to 2021, scientists identified 12 strong Milky Sea candidates across the Indian Ocean and Western Pacific. The largest was the 2019 event south of Java. That glowing region covered more than 100,000 square kilometers and remained detectable from late July into early September. The Ganesha sailed through it for about 8 hours. Its crew reported that the ocean was brighter than the sky. Their route and photographs later matched the satellite observations. Satellites can now locate and track these events, but they cannot reveal exactly which organisms are present, what chemicals are in the water, or what caused the glow to begin. Scientists must reach an active Milky Sea while it is still shining. The next encounter could solve a mystery that has survived for centuries. It may reveal how trillions of bacteria communicate across an enormous region of ocean, and whether the glow signals a thriving ecosystem, a stressed one, or something in between. We can now see these ghostly oceans from space and follow them for weeks. Yet one question remains unanswered. Why does the ocean sometimes turn on the lights?